Hello, my name is Cal. I'm just doing problem from the book Physics for Science and Engineers from chapter 2, number 23 for Physics 221. And the question is, when a jumping flea accelerates an astounding 1,000 meters per second square, but over only a very short distance of 0.50 millimeters, if a flea jumps straight up and if air resistance is neglected, a rather poor approximation in the situation, how high does the flea go? So, the first thing we do is write down our knowns. Our known information is the acceleration is 1,000 meters per second square, and our change in height, which is in y direction because it is moving upwards, is going to be 0.5 millimeters, which is 0.5 times 10 raised to minus 3 meters. And our required and the quantity we're looking for is the final distance which the flea would be traveling in the y direction. So our first assumption is going to be, since the flea will be traveling upwards, our acceleration is going to be a positive number, which is positive 1,000 meters per second square. And our initial velocity, which I put right here at v0, it's going to be 0 because it is going to be starting at 0 velocity. As it is moving upwards, it's going to gain some velocity, which I put as v1, and as it is at its maximum height, it's going to turn and come down. At that area, it's going to be velocity 2, and our velocity 2 is going to be 0 meters per second because our slope is going to be 0 right here. So with that assumption in mind, our v0 and our v2 0 meters per second, one thing we can do is just use the formula that is given in the book, which is final velocity squared minus initial velocity squared should equal to 2 times the acceleration and change in the distance. So using this, we can find our v1, which is the only velocity for this flea. And to find that, all we have to do is just substitute all the numbers we have. Our v0 is going to be 0, so we can cancel that out as 0. And we're going to solve for our v1, which is going to be equal to 2 times the acceleration, which is 1,000 meters per second square, times 0.5 times 10 raised to minus 3 meters, so that the meters can cancel out and we would only have our meter per second square. And our v1 just becomes 1 meter per second, because it's just going to be 2 times 1,000 times 0.5, while in free fall motion, because once it goes up, it's going to come down. The acceleration is going to be negative of the gravity, because we're just giving it the negative value to indicate the direction is going to be downwards. Our v1, once we calculated 1, and our v2 is going to be 0 because it's going to be at top. When it's turning direction and it's coming down, our slope is going to be 0. So using the same formula, we're going to find our change in y, which is going to be the distance that is going when it's in free fall. Like we did on the first one when we were trying to v1, we just substitute everything we have, and our change in y becomes velocity 1 squared over 2 times acceleration, which would be 1 over 2 times 9.8 meters per second. So our change in y, once we divide 1 by 2 times 9.8, we get 0.051 meters, which is 51 millimeters. Since the distance, since it is distance, even if it is a negative number, the negative only indicates the direction is going to be downwards. So we don't actually have to write negative 51 millimeters. We know it's going to be downwards because it is in free fall. So the final height the flea would go with the given acceleration, that is 1,000 meters per second squared, is going to be 0.5 millimeters plus 51 millimeters, which will end up being 51.5 millimeters or 0.515 meters. Thank you.